Okay, today we'll study gamma distribution, chi-square distribution, and beta distribution. So gamma function is first defined. So this for positive alpha, this integration is finite because because this from 0 to 1, this is dominated by right dy, and from 1 to infinity, this guy is dominated by some this one dominated by some constant, right? dy. So this is finite. So this gamma function, the property of gamma function follows has these three properties. First, if you okay, let me write it this way. So 0 to infinity, y alpha minus 1, e minus y dy. So if you use integration by part, you can actually obtain something like y minus 1, e minus y integration minus y. So this is actually minus y, right? And then plus 0 to 0 to infinity inverse prime minus minus plus minus. So what I'm trying to do is prime minus e minus y dy. So that is the first part is 0, and second part is plus 0 to infinity alpha times alpha minus 1 times y alpha minus 2 e minus y dy. So this is a gamma function with this parameter. So we have this result. And interesting part is if alpha equal to 1, right? Then what? Gamma 1 is 0 to infinity alpha equal to 1 e minus y dy. So that is 1. So if you can immediately see that if for integer alpha, this is factorial because so basically if you gamma n minus 1 times gamma n minus 1, which is minus 1 n minus 2 gamma, right, n minus 2, something like that. So if you keep doing this way excuse me, so this one times 2 times gamma 1, which is 0, which is 1. So basically factorial. For the third part, gamma half is 0 to infinity y minus half e minus y dy. So if you use square root y equal to t minus root 2, you can write it as a root 2 divided by t times e minus 2 t square Jacobian, which is dt, right? So so that sorry, that is square root of 2 times 0 to infinity e minus 2 t square to pi to t. This is using the PDF of normal distribution. This is square to pi, so that is okay, sorry, times half, because PDF is from minus infinity to infinity. T squared dt is equal to pi. So we from 0 to infinity is basically half. So that is square root pi. Okay. Gamma distribution is essentially so two parameters, alpha and beta, gamma distribution alpha beta is this parameter, this form. So integration between 0 to infinity f x is basically, you can write it 0 to infinity beta over x alpha minus 1 e minus beta x, right? And then beta over x dx. So that if you do change your variable y equal beta x divided by beta, then this is the same thing. So y alpha minus 1 e minus y dy. So that is gamma function. So that it gives 1. So that is the well-defined PDF. And you can derive the MGF easily. So the MGF of gamma alpha beta is expectation of the ETX, which is integration of ETY TX times PDF, right? Gamma alpha beta alpha x alpha minus 1 e minus beta over x dx. So how to compute this? Well, the key idea is to recognize that, okay, you can actually simplify some constant here, and then key part is to recognize that it's x polynomial part and then exponential part, right? So minus beta over minus. So that how well, you can probably write it as a okay, beta minus 1, right, minus tx. So what is this? Well, if you write it as alpha minus 1 e minus beta prime, another beta, right, dx. If you write this way, this integration is gamma alpha beta prime alpha, right? Because the form of the PDF, you can write it this way. So all you have to do is compute this ratio. So the whole ratio is gamma beta prime alpha divided by alpha beta alpha, where beta prime is beta. Okay, so beta prime. Okay, beta prime is 1 minus beta minus t divided minus 1, right? 1 over. So that that gives the 1 minus beta t minus alpha. And of course, in order to make the integration finite, we should this should be included. Okay, so from that we can easily compute the mean and variance using the MGF. Or if you want, you can actually use the integration directly. For example, how to compute the integration from the PDF directly, where so it's X, right, and then PDF. So then basically you have the constant term, and then new term is essentially alpha plus 1, alpha plus 1, because you have a new because if you why because if you consider this one, right, this one is alpha x alpha, so that is alpha plus 1 minus 1, so that is a new shape parameter, so that gives alpha times beta, so that is the expectation, something like that. Okay.